All right. Hello, everyone. Robotics right now is going through a moment of tremendous change where we can now teach robots just by showing them what to do instead of having to program procedurally step by step. So today I'm going to talk a little bit about my company's Standard Bots, what's going on in AI and robotics and why it's so exciting and the problems it can solve. A quick overview of end-to-end robotics models and how to collect data and some tasks that are appropriate for AI and some takeaways. Is there a back button on this thing? Oh, sorry. Can you go back a slide? Apologies. Back one more. No back button on this. Sorry, one more, I think. I hit it like 5 times. Okay, there we go. So we're a company based here in New York. We make the AI platform, the software and the hardware for robotic arms. We're deployed from companies like Lockheed Martin down to small mom and shops. We raised 65 million from General Catalyst and others and growing really quickly. The problem we're trying to solve is that robots today are too hard to program and they're too limited in what they can do. So robots, pretty much all of them are programmed in this really procedural kind of step-by-step way where you set a point here and here and here, and then it can replay through the points. But that's pretty limiting. It's very hard to do a lot of tasks that way. And this is at the same time a really important problem to solve because by automating, we can lower the cost of production, food and other items for people who can't afford it. It's better for the environment, it's better for national security. So those are the problems we're working on solving by making robots more capable. This is just a quick preview of our robots and what they look like. This is our first product. Video is lagging a little bit, but that's welding and machine tending. Too many slides in the deck. There we go. And then, so we go from single arms to this droid-like form factor, which is sort of like a humanoid, but it is lower cost and more range of motion, higher speed. So we think it's superior to kind of traditional legged humanoids in almost every way for manufacturing type tasks and warehousing type tasks. So and then we have these kind of like Lego type building blocks. So you can deploy single arms, 2 arms stationary, 2 arms mobile. You can add a lift. So we're really providing this kind of like Lego-like kit for anyone trying to automate so they can have whatever the right solution is for their job. Trying to go through the concrete pole here, maybe. There we go. We vertically integrated, so we designed our own motors, motor controllers, gear units, all the parts inside the arm. And we've got better specs than others. And we try to make the UI like really simple and easy to use. So that's a little bit about us. But on to the AI section. So why do robots do so little of our physical work today? It really comes down to there's so much variability in the real world. Like if you take assembling iPhones, Tim Cook said that the software on the iPhone is not good enough to bring back manufacturing to the US for iPhone assembly. And the thing that makes that hard is there can be variability in the torque when you try to turn the screws. There's variability in the parts and how they fit together. The parts can look slightly different, as they're manufactured in different batches. So there's so many things that vary in the real world that you have to be able to handle that a human can just handle without thinking. And it's about 6 hours today still to assemble an iPhone. So there's this huge queue of tasks that with end-to-end AI models and training through demonstration that robots are going to be able to automate. And sorry, I'm having some trouble with the clicker. There we go. And this is what we're seeing this trend in self-driving right now. So in self-driving, the models used to be mostly just for perception. And they would find the lane marker, find the stop sign, and you would write procedural code to drive the car. And what's happened is we've moved to a world where, and all the top like Tesla and Waymo, they're now creating these more end-to-end models where the robot takes in the sensor data and it outputs a trajectory for the vehicle. And then safety system decides which trajectory it can execute, but it's pretty much end-to-end. And that's exactly analogous to what's happening with robotic arms right now, where you can go from camera data in to the actual trajectory of the arm to perform the task. The inputs are camera data, tool position, gripper state. Outputs are, the real time, like where you want the arm to move. Here's an example. This is on the left is a device, like an example of a device you can use to collect this kind of training data. So you just perform the task with this. It's recording the video, the position of this handheld device as you're moving it through space. And on the right, it's doing the pouring autonomously. Here are a couple other examples. So on the left, you can see the model is resilient to the location of the objects, the type of can, where the cup is that it's pouring into. And so these models learn to generalize between the training data that you show them. So if you show, locations all around the table where you want to pick up the cup, it can fill in and it can automatically pick up at locations between those. Or if you show it a couple different can types, it can generalize to new cans it hasn't seen before. So it's really, really powerful to be able to handle this type of variability that limits robotics today. On the right here, you can see as it's going to pick up the can, if you move it, it can actually correct in real time. And it starts to feel like magic where, it's trying to perform the task, things might go wrong, and it can just kind of like correct, like it's almost like it's thinking to perform the task, which is really cool. A couple other examples here. This is battery insertion and cleaning up a spill on the right. So these traditionally would be tasks because of the variability that would be hard to automate if you were to call an integrator. I'll go through a couple ways that you can collect data, training data for robotics now. This is a leader-follower method, or mini-arm tele-op. So as you move the small arm, it's moving the bigger arm, and you're kind of guiding it through space. This is good because you can control the whole position of the arm. So, if you want to control the elbow location, for example, and you can avoid singularities that way because you're kind of directly controlling from the small arm to the big arm the joint positions. This is a handheld device. This is really good if whatever end tool you're working with doesn't weigh very much. So this kind of breaks down if you have an end tool that weighs like 10 pounds because it gets very heavy on the arm. But this is a device we made. It can record forces, it can record positions, it records the camera data. So you're collecting, it's basically the end of the robotic arm, and you can put any different kind of gripper on there. And from the perspective of the training data, you can't tell that you're not on a robotic arm. And then here's teaching through the pendant. So you can move our teach pendant through the air, and that moves the tooltip of the robot in sync. So this is another way to collect training data. And finally, VR is another way where you can wear a headset and you're seeing through the view of the robot, and as you move your hands, it's moving the robot tooltips around. So great AI tasks in robotics today are generally they're short. So really long horizon tasks are not solved yet, still an open problem. Generally, you want tasks that are going to be in distribution for the training data that you've collected. So if you expect to see things that are way out of distribution, then models can't generalize that well today. It's simulatable, then that's good too, because you can collect data in simulation. And there's a lot of pieces here. We're really trying to sit in the center and make this super simple for customers. The really cool thing about this end-to-end approach is you can automate tasks that, number one is you can do things you couldn't do before, which is really important because robots are so limited and penetration rates are so low even for the most common tasks. So that's the most important thing. But it also makes programming a lot easier because you don't have to be an expert anymore in robotics to program an arm. You can just demonstrate the task. So you just need to know how to do whatever you're showing the robot. And then I mentioned and showed the video of how it can correct in real time. So if something goes wrong, it drops apart, you can have these you can have these sequences. If you have that in your training data, it can automatically take care of deviations from the expected happy path. For any robotic arm to do to run control from these kind of models, you're going to want real-time position and gripper control. So you want to be able to stream positions to the arm at low latency and have it follow those really accurately. Generally, it's good to have joint torque sensing and impedance control that's really strong, because for most tasks, you have to interact with the world. So if your arm doesn't have good joint torque sensing or impedance control, then it hits the table, throws a collision, maybe pushes too hard on the table and damages it. Or if you have a sensitive gripper, like a human hand type gripper, if you push too hard, it can break. So that's an important requirement. And then bimanual or two-arm support is really important for many tasks, because you can hand off objects, and you can, just like we use two hands to work together, it's important often for some tasks. Simulations role, so similar to self-driving, in robotics, simulators can prevent costly mistakes in the real world. They let you iterate more quickly, so if you want to change your model architecture, you can just test in simulation rather than having to test in the real world, which can be really, really expensive. And then sometimes it can be really costly to collect training data. So if you're working with a machine that's really expensive and you can't bring down, or you're working with plants or something like, there's a lot of cases where it is expensive to collect training data in the real world. So simulators are great for that. And then you can also collect data around a lot of edge cases, which is obviously how self-driving uses simulation. So this is what we're building, the platform for applied AI in robotics, where we make it simple, and this is something we'll be rolling out next year, where anybody can sign up. You can collect training data for robot arm, train your models, label and organize your data, deploy those models, end to end, get all the jobs done. Data collection flows, guiding the user through how many demonstrations they need. You can label different parts of your task and manage all your models. So a couple takeaways: end-to-end robotics, it's pretty much zero deployments almost right now, but this is going to be something that grows extremely quickly. It solves so many problems, so that's why we're really excited about it. The ROI for tasks, we think, will be much higher, because not only because you can perform tasks that you couldn't before, but it's easier to set them up. And you can have, like often in robotics, integrators will set up whole different systems or custom end effectors when you have part variability. Now you can have a lot less variation in the hardware or the robot program. You can have the same setup handle many more parts. So that leads to higher ROIs. And then a lot of the advancements we're seeing in LLMs and otherwise in the space and GPUs, that's all going to help robotics models, and it's going to increase the capability of these models over time, so we can do more and more. And then finally, next year, we, possibly among others, will launch a platform for this. So anybody can train these models, and it's easy to partake and actually deploy them, beyond what you can do with being an engineer with some open source. So that's all I got for today. Thank you all very much.